Welcome to this video on Combinatorics. In this segment, we will introduce you to the basics of combinatorics and its importance in mathematics. Combinatorics is a branch of mathematics that deals with counting and arranging objects. It is a fascinating field that has applications in various areas, including computer science, physics, and engineering. The fundamental concept of combinatorics is the counting principle, which states that the number of ways to do two or more things is the product of the number of ways to do each thing separately. For example, if you have 2 shirts and 3 pants, the number of ways to choose 1 shirt and 1 pant is 2x 3 equals 6. Combinatorics is divided into 2 main areas, permutation and combination. Permutation deals with the arrangement of objects in a specific order, while combination deals with the selection of objects without regard to order. The importance of combinatorics lies in its applications in various fields. For example, in computer science, combinatorics is used to analyze algorithms and data structures. In physics, combinatorics is used to study the behavior of particles in a system. In engineering, combinatorics is used to design efficient systems and processes. In the next segment, we will dive deeper into permutation and combination and explore their applications in real-life scenarios. Welcome back. In this segment, we will explore permutation and combination in more detail. Permutation is the arrangement of objects in a specific order. For example, if you have 3 letters A, B, and C, the number of ways to arrange them in a specific order is 3. 3 factorial equals 3x 2x1 equals 6. The 6 possible arrangements are ABC, ACB, BAC, BCA, CAB, and CBA. Combination, on the other hand, is the selection of objects without regard to order. For example, if you have 3 letters A, B, and C, the number of ways to select 2 letters without regard to order is 3C to 3 choose 2 equals 3. The 3 possible combinations are AB, AC, and BC. Permutation and combination have various applications in real-life scenarios. For example, in a lottery, the order of the numbers matters, so permutation is used to calculate the odds of winning. In a committee selection, the order of the members does not matter, so combination is used to calculate the number of possible committees. In conclusion, permutation and combination are essential concepts in combinatorics that have various applications in different fields. In the next segment, we will explore more advanced topics in combinatorics, such as the inclusion-exclusion principle and generating functions. Welcome back. In this segment, we will explore the inclusion-exclusion principle, which is a powerful tool in combinatorics. The inclusion-exclusion principle is used to calculate the number of elements in the union of 2 or more sets. It states that the number of elements in the union of 2 sets A and B is given by a B equals A plus B a B, where A represents the number of elements in set A, B represents the number of elements in set B, and a B represents the number of elements in the intersection of sets A and B. The inclusion-exclusion principle can be extended to more than 2 sets. For example, the number of elements in the union of 3 sets A, B, and C is given by a BC equals A plus B plus C a B a C BC plus a BC. The inclusion-exclusion principle has various applications in combinatorics. For example, it can be used to calculate the number of derangements, which are permutations in which no element appears in its original position. In conclusion, the inclusion-exclusion principle is a powerful tool in combinatorics that can be used to calculate the number of elements in a union of 2 or more sets. In the next segment, we will explore generating functions, which are another important concept in combinatorics. Welcome back. In this segment, we will explore generating functions, which are a powerful tool in combinatorics. A generating function is a formal power series that encodes the sequence of coefficients of a combinatorial sequence. For example, the generating function for the sequence of Fibonacci numbers is fx equals 1 plus x plus 2x2 plus 3x3 plus 5x4 plus 8x5 plus, where the coefficient of xn represents the nth Fibonacci number. Generating functions can be used to solve various combinatorial problems. For example, the coefficient of xn in the generating function for the sequence of partitions of n represents the number of ways to partition n into distinct parts. Generating functions can also be used to solve recurrence relations, which are equations that describe a sequence in terms of its previous term. For example, the Fibonacci sequence is defined by the recurrence relation fn equals fn-1 plus fn-2. Using generating functions, we can derive a closed-form expression for the nth Fibonacci number fx equals 1/1xx2. The coefficient of xn in this expression gives us the nth Fibonacci number. In conclusion, generating functions are a powerful tool in combinatorics that can be used to solve various combinatorial problems and recurrence relations. In a final segment, we will summarize the key concepts we have covered in this video and provide some additional resources for further learning. Welcome to the final segment of this video on combinatorics. In this segment, we will summarize the key concepts we have covered and provide some additional resources for further learning. Combinatorics is a branch of mathematics that deals with counting and arranging objects. It is divided into two main areas, permutation and combination. Permutation deals with the arrangement of objects in a specific order, while combination deals with the selection of objects without regard to order. The inclusion-exclusion principle is a powerful tool in combinatorics that can be used to calculate the number of elements in the union of two or more sets. Generating functions are another important concept in combinatorics that can be used to solve various combinatorial problems and recurrence relations. Combinatorics has various applications in different fields, including computer science, physics, and engineering. It is a fascinating field that offers many opportunities for research and exploration. If you're interested in learning more about combinatorics, there are many resources available online. Some recommended resources include Concrete Mathematics by Ronald Graham, Donald Knuth, and Orrin Patashnik. Combinatorics Topics Techniques Algorithms by Peter J. Cameron. A course in combinatorics by J. H. Van Lent and R. M. Wilson. In conclusion, combinatorics is a fascinating field of mathematics that offers many opportunities for exploration and research. We hope this video has provided you with a good introduction to the key concepts in combinatorics. Thank you for watching.